In the previous episodes, we have seen some of the basic concepts. So I thought I would discuss some topic which is considered an advanced topic. It's RBAC, or role-based access control. Using this approach, we can add constraints to access Kubernetes resources. RBAC is used by Kubernetes for authorization. For example, giving access to a user, adding or removing permissions, and setting up rules, etc. This adds security to a Kubernetes cluster. There are 3 key points of RBAC. The first one is subject. Subject could be users, groups, or service accounts. The second key point is resources. Kubernetes API objects, which we will operate on, are resources. And the third one is verbs. The operations which we want to do with our resources are called verbs. So why do we need RBAC? In a business with multiple teams and departments accessing the Kubernetes cluster, each person needs to have some amount of security from one another. A member in one team may be accidentally interfering with the other team's work. One developer might accidentally delete the work of someone else. Or worse, one member can accidentally gain visibility into a secret project. In these cases, RBAC is mandatory. By default, RBAC is enabled in Kubernetes. The RBAC API declares 4 kinds of Kubernetes objects: role, cluster role, role bindings, and cluster role bindings. We can describe or amend them using tools like kubectl. Let's first see role and cluster role. An RBAC role or cluster role contains rules that represents a set of permissions. Permissions are purely additive. That means there are no deny rules. A role always sets permissions within a particular namespace. When you create a role, you have to specify the namespace it belongs in. Whereas a cluster role is a cluster-wide role, as the name implies. The resources have different names, role and cluster role, because a Kubernetes object always has to be either namespaced or not namespaced. It can't be both. Cluster roles have several uses. They can be used to define permissions on namespaced resources and be granted within individual namespaces. They can define permissions on namespaced resources and be granted access across all namespaces. They can also define permissions on cluster scoped resources. The bottom line is, if you want to define a role within a namespace, use a role. If you want to define a role on a cluster-wide basis, use a cluster role. A cluster role can be used to grant the same permissions as the role. Because cluster roles are cluster scoped, you can also use them to grant access to cluster scoped resources like nodes, non-resource endpoints, and namespaced resources across all namespaces. Now let's discuss role binding and cluster role binding. A role binding grants the permission defined in a role to a user or set of users. It holds a list of subjects, users, groups, or service accounts, and a reference to the role being granted. A role binding grants permissions within a specific namespace, whereas a cluster role binding grants that access cluster-wide. A role binding may refer any role in the same namespace. Alternatively, a role binding can reference a cluster role and bind that cluster role to the namespace of the role binding. If you want to bind a cluster role to all the namespaces in a cluster, use a cluster role binding. One important thing is, a role binding can also reference a cluster role, and it can grant the permissions defined in that cluster role to resources inside the role binding's namespace. This kind of reference lets you define a set of common roles across your cluster, then reuse them within multiple namespaces. To grant permissions across a whole cluster, you can use a cluster role binding. After you create a binding, you cannot change the role or cluster role that it refers to. If you try to change the binding's role reference, you will get a validation error. But then if you do want to change the role reference for a binding, you need to remove the binding object and create a replacement. So Rbac can be used to grant permissions for users, groups, and also service accounts. So let's talk about service accounts a little bit. In Kubernetes, service accounts are used to provide an identity for pods. Pods that want to interact with the API server will authenticate with a particular service account. By default, applications will authenticate as the default service account in the namespace they are running in. This means, for example, an application running in the test namespace will use the default service account of the test namespace. Applications are authorized to perform certain actions based on the service account selected. We currently allow the following service accounts. The first one is kubesystem:system. This is used for admin access in the kubesystem namespace. The second service account is kubesystem:default. This is used for read-only access in the kubesystem namespace. The third one is default:default. This gives read-only access to the Kubernetes API. And the fourth one is *operator. This gives full access to the used namespace and read-write access to TPR, storage classes, persistent volumes in all namespaces. We should also note that additional service accounts are used by Kubernetes Control Manager to allow it to work properly. So this is it for this episode. As always, you can write to me at kubernetes@cent.com. And that's it for this episode. Thanks.